All right, so we're going to talk about 3 different fields today. And this is in a hope that we can, see where we have commonality, see where we learn. In a lot of ways, there are some things that are shared between software engineering and medicine or aviation. But the biggest one that I'm going to dive into today is complexity and high stakes. So, complexity, that one's pretty easy to define. You have complexity in medicine. They have so many different medicines and procedures and operations that they need to learn. Aviation, it used to be simpler to fly planes. For a while there, you'd get trained and then you could just fly it, just like the personal aircraft. But as time went on, there were different things that were needed for aircrafts to have them be more advanced, and it became very complex. And software engineering, depending on what system you're building, that can get more and more complex. So in a lot of ways, we're all concerned with complexity. Now let's talk about high stakes. I know that's a big claim. I know there are a lot of people who suffer from the high stakes in software engineering, especially carpal tunnel. But no, just joking. You might be thinking these aren't in the same realm, and in a lot of ways, you're right. Aviation and surgery, they're literally life and death sort of situations. Those are the stakes there. And software engineering usually isn't. Now there are a few, cases where it can be. But I just want to say this. Bugs can take down businesses. You can expose personal data, and you can erode trust, cost your company millions of dollars, and cause real-world harm. So I'd consider those pretty high stakes. All right, so how do you manage this complexity and reduce these risks? We're going to go through a few case studies from aviation and from surgery to see what we can learn from it and find out. All right, so the first case study we're going to go through is in aviation. This picture here is of the B-17 bomber. Back in 1935, this was developed by Boeing. And the U.S. Army Air Corps, they decided to have this flying competition where they were looking at what aircrafts do we want to buy. And so they had these manufacturers compete to be the choice for the Army. In many ways, it was kind of a mere formality because this top entry, it was already the one that was claimed. The Army had already said they're going to buy 65 of them, and if that goes well, they'd buy more and more. So, in a way, with this one, as it was designed, the Army, they requested it. They said, we want it to have X number of bombs. We want it to be able to fly so far. That way it can meet all the needs of the time. And they actually were able to deliver. They made this, and it was able to carry 5 times the amount of bombs that were originally requested. It was able to go faster and further than any bomber previously made. So it was kind of a shoo-in. So, on the day of this test flight, there were 5 crew members to this plane. They all loaded up. You had a pilot, 4 other crew members to help with various things. And they took off. They climbed to 300 feet, and that's when disaster struck. The plane stalled, and it turned on one wing, and it crashed in a fiery explosion. 2 of the crew members died, including the pilot. After an investigation, it was found that the plane worked perfectly fine. This was a pilot error. And after that, they were looking at it. They were like, "Hey, this plane is vastly more complicated than any other plane we've seen before." The pilot, while flying, had to monitor 4 engines, no longer the 2 that they had previous to this. There was oil fuel for each, retractable landing gear, wing flaps, electric trim tabs, and constant speed propellers. And a lot of people were asking, is this too much of a plane for men to fly? So, how did they solve this issue? So they still ended up buying those planes, the U.S. Army, and they got a group of their test pilots together to figure out what to do. How can they make sure this never happens again? Should they train the pilots more? Do they need to simplify the plane? No, they actually kind of needed all the things the plane was offering. So they actually came out with checklists. This is the first time they came out with a pre-flight checklist for an airplane. Like there's these things you just got to remember, and it's too much to just keep in your head. So, one of their core things is these checklists, they need to be short enough to be on an index card. So they had checklists for takeoff, for the flight, for landing, for taxiing. A lot of it was like the stuff pilots already knew how to do. A lot of it was like the dumb stuff. But there were like just things that they found were important. And outside of these, they even thought of different situations. What do you do if your plane stalls? What happens if your engine goes out? And if you're familiar with the whole thing with, I can't remember his first name, but Sullenberger, with the whole like landing on the Hudson, they had something in their checklist book that was for this situation where an engine goes out and they need to figure out what to do. So let's talk about the outcome. The outcome with this checklist in hand, as they used the B-17 bomber, is it was able to be flown 1.8 million miles without a single crash. Like, it's just mind-blowing, and it's just because of a checklist. So the Army ended up ordering 13,000 of these, and as World War II came around, they had a big advantage having these bombers that were able to do so much and give them so much advantage. All right, let's talk about surgery a little bit. Okay, I took some notes on my phone. One second. Apologize. Okay, I want to tell you a story. So one day there's this family, and they were at this pond. They weren't there to be in the pond. It was kind of in the north where it was really frozen, and they're just hanging out. Their 3-year-old daughter fell through the ice. The parents, they frantically were going through, trying to break through the ice, get their daughter out, but it took a while. Like, we're talking about 30 minutes to finally get her out. They call 911, and the 911 operator heard the situation and instructed them to do CPR. 8 minutes later, medics arrived. They checked her vitals. No pulse. Her temperature was at 66 degrees. That's 30 degrees off where it should be. And her pupils weren't dilating, which is a sign that there could be really big impacts to the brain, or that it might not even be functioning at all. So they continued the administering the CPR. They were able to take her by helicopter to the hospital. And once they got to the hospital, they didn't go to the emergency room. They were able to go straight to an operating room. And from there, the team were able to work out and talk amongst themselves on how to save this girl. So, this isn't a super common thing that many ERs or operating rooms have to deal with. They needed to, let me see what the word of it. They needed to get her on cardiopulmonary bypass. That means cutting in, getting into the heart, connect tube, an outtake tube, get it all working so they can have blood flowing through her body. An hour and a half later, she had circulation. They kept going because, especially when they see this poor little girl in front of them, there's like, we got to try. We got to try our very best. Kept going. After 2 hours, they were able to warm her to 76 degrees. Later, the heart started beating. They were able to warm her to 98.6 degrees, the normal temperature, after 6 hours, get her lungs to work using a mechanical ventilator. But what they found is her lungs were full of pond water and debris, and they couldn't really have her lungs working. So they sent her to the ICU. They pumped out the water over the next 24 hours, got the debris clear, and they got her to a point where her lungs were able to work again. They, at that point, closed her up, administered certain drugs and therapy because her liver was really shot. And after 48 hours, they were able to get all the organs working again, except the brain. From here, they did a CT scan and realized that there was too much pressure. Her brain was just expanding, and so they had to drill holes in her head. They reduced this pressure, and it gave the brain room to swell out and be able to manage itself. She was in a coma for a week. Later, she came back. Her pupils were dilating again. Her breathing came back. And a week later, she went home. Now, she wasn't without harm. After all this, she was paralyzed on one side and her speech was slurred. But there's like a lot required to get her to this moment. And after some physical therapy, and everything, and operational therapy, they brought her back 2 years later and ran some tests. There's like, hey, how much was she impacted mentally from this? What is her state? Is she maturing as she ought to? And what they found is she was just like any other normal girl at that point. You can compare her to anyone else. They had fully saved her. Her speech was back. How she was paralyzed on the right side, that went away over time. And so, this was a huge deal in the surgery community. And there's a surgeon who's pretty well known about 10 years ago who looked at that and he's just like, hey, like there's a lot of complexities here. This wasn't one person executing a task. This was like dozens of people coordinating together. So let's talk about medicine for a little bit, and we'll come back to this story, and I'll show you how it applies later. So, coming into the 20th century, a lot of what doctors did is they had a handful of remedies that they knew worked, and they would apply them. There wasn't much complexity. But, as time went on, there were a ton more complexities added. So let's talk through some of those. So they have over 13,600 different diagnoses, 6,000 drugs they could administer, over 4,000 medical procedures. And about 10 years ago, there were also a lot of failures. Given all that complexity they had 40% of people that had cardiac disease, they had incomplete or inappropriate care in the US. They weren't fully taken care of. 60% of pneumonia that was bad enough to put them in the hospital had incomplete or inappropriate care. And I don't remember if this one, when I was this number, I didn't know if it was each year or just during a different span, but 2 million people roughly pick up infections while in the hospital just because of, maybe neglecting to wash your hands. So there's a lot of things that happen. Now I want to talk about like this one thing that a lot of philosophers bring up at times when they talk about failure. One of those is failure because of ignorance. So as we're filling the gaps and learning more things about medicine, about engineering, about aviation, in the early days, there was a lot of ignorance. And if someone was failed to be revived from something like this girl who almost drowned, it would have probably been because of ignorance. We didn't really have the know-how. Ignorance, sometimes it's one of those things where, we have hope that one day we'll have the information needed to overcome different challenges. That brings us to the other failure mode, ineptitude. We live in a day where there's so much knowledge. There's a lot of things that have been solved. And ineptitude is when someone fails to apply knowledge that we have in a situation and it results in a failure. And this is one that's harder to forgive, I think, for many people, especially when it's in a medical case where someone goes in for surgery, they come out disabled, and maybe later they find out this didn't have to happen. The surgeon should have done something else, and maybe they either forgot or they didn't know. So, this is a hard one to grapple with for some people. And in the medical field, just to kind of finish up this case pretty soon here, there's 250 billion operations every year, and about 50 million a year in the US. Now, a lot of the stats back where I got some of these sources, they said a lot of the complication rates are around 3%. It's like, okay, that's pretty good numbers. Except when you're at that magnitude of operations and you have 3% of them go wrong or not as expected, it's a big deal. That can mean about 500,000 people leaving surgery disabled. That can mean 150,000 people die in the surgeries. So the surgeon, he was tasked with finding out, how can we reduce this number? So overall, there's different ways you can approach this. One thing you can think about is, all right, if we have the knowledge, can we just train people better? Or, could we just have specialists? And that actually works quite a bit. In our industry, you might have people who specialize in database, back end, front end. In the medical field, you might have people specialize in different types of surgeries. I know there are many people even who do cancer surgery who specialize in particular cancers. So you can't have specialization, and that can limit the things that can go wrong. But at a certain point, you can't specialize enough to overcome human weakness. And so, this surgeon, he noticed that one thing about the B-17 bomber. He's like, okay, they went from having this disaster to never seeing that disaster again, just by adding a checklist. So he's like, can we try that in the medical field? So they introduced a checklist to 8 hospitals. And this is kind of mind-blowing. This is 2015. So this is 10 years ago. A lot of hospitals weren't using checklists. They kind of did a lot of things word of mouth. Maybe they had their own things. Maybe some of them were using checklists, but they didn't have anything official for different operations. So they decided to introduce a simple checklist to their operating rooms. They used it in those hospitals for 3 months with over 8,000 patients. And as a result, every hospital had a double-digit reduction in their complication rates. Less death, less disability after that. Averaged at 36%. Compared to hospitals that weren't using a checklist, they had 27 fewer deaths per hospital when they were using checklists. And that's and just to compare, that was a 47% reduction in deaths. Not only that, is this didn't cost anything, really. You just had to think about what are the things that go wrong in a given operation, or even just think about operations in general. How can you come up with a good checklist to avoid different failure modes that they deal with? Now let's talk about experts. Some of you in this room might consider yourselves experts in software engineering. What if someone told you, you got to follow this checklist? You might think that's for the new guy. That's for the person who doesn't know what they're doing. And kind of goes against what some people might believe an expert to be. Some people think, I've earned this right to know my craft so well that I don't need a checklist or anything else to remind me of what I should do. I just have it inside me. And it kind of goes to pride. You might just say I got this. And if I fail, I guess that's possible, but it's not going to happen to me. Some people might think that. Now with this hospital idea, after 3 months, they did some polls with the surgeons. They said that 80% of people, they said it didn't take too long to complete. It improved their communication and teamwork, made surgery safer, and it usually saved at least 1 error per week for them. Now there's the other 20% who they hated it. They thought it was a waste of time. They're good at what they do. It's just more paperwork. If they had an operation, then they were all asked, if you had an operation, would you like the surgeons in the room to use that checklist? 93% of people said that they would like the checklist. So the adoption's kind of interesting because, if you have these results, and they're mind-blowing numbers, 47% reduction in death. If this was a pill, there'd be ads for it everywhere. It'd say every hospital must do this. It's life-changing. It's saving so many people. But most people, they think about it and they're like, checklist? Really? Should I pay attention to that? Some other people, they had worries. They're like, if I have a checklist in my job, won't that take the joy out of it? Won't it take the autonomy out of it? Won't it just mean people are just telling me what to do? And what some people can conclude that, But in a lot of ways, when you live in a world of complexity, and you're in a situation where like failure could mean a whole lot to you, having many people with full autonomy that need to coordinate with each other, it can be a complete mess. And so, if your task is to be effective and you can get satisfaction through your job by being effective, in these cases, they just said, you should just try out the checklist and embrace it. All right, so let's talk about that girl one more time, and then we'll continue and we'll go into talking about a few other things. Okay, so this girl, the guy, the surgeon tasked with the World Health Organization to create this checklist and who had those amazing results, he found that study and was inspired by it. And then he contacted the person who was the lead surgeon in there. It's like, what did you do? How did you have that girl life flighted and go straight to the operating room, have everyone where they need to be? And his answer was checklists. He's like, over the last many years, we've been trying to solve this one. We've had patients come in and we failed to resuscitate them. And over time, he started identifying that the problem was lack of preparedness. People weren't prepared or given enough notice to have certain things ready to be able to solve the issues that they were running into. So they instituted checklists, and they gave the checklist to people with the least power. They gave one to the 911 dispatcher. Her checklist is, if you run across someone who is in this situation, have them do CPR and then contact this list of 5 people. And those 5 people, they all have their checklist that have, maybe 5-6 items on it. And from there, they were able to have all those sequence of events lead to the hospital, to the ICU, and having repeated processes in place to clear the lungs, and for the neurosurgeons to know what to do if they have a situation where the brain's swelling like that, and who's monitoring what, and just all the different coordination in the different pause points. So what might a surgical safety list look like? This might be a little hard to read. I'll just run through it real quick. What they realized is, in a natural process where you're trying to do something, you gotta find those pause points where someone's gonna take out a piece of paper, run through something. What they realized is, one place is right before anesthesia. That's a good pause point. So they made sure that they had the right person, that they had the right procedure, they're doing the right thing, that the site's marked, that they have everything they need. Are there allergies that you might not know of? And are there any risks? And then before the incision, one of the big ones that had a huge impact was, did they have an antibiotic? I didn't know this, but most operations, if not all, you give an antibiotic before you cut open. I mean, I guess I should have known that. It's pretty clear that, like, you're going to be open, you don't want infection. That can kill you. And so many times that was a key part of their checklist is, do they have the antibiotic? And if not, now's the time to hurry and get that in before they actually cut. And so they found these pause points, and I think that's the key to look at here, minus all the words. They found these pause points to look at the things that could go wrong, or even like have a part right here. Does the surgeon, the surgeon has certain context that maybe everyone else doesn't have. How long is it going to be? Is there going to be blood loss? Are there any critical steps that people need to be aware of? And even some open-ended ones, like to the anesthesiologist, are there any patient-specific concerns? And it's like these checkpoints to communicate. All right, so, why should we use these in engineering? Well, depending on what you're doing, I know from my experience, sometimes I forget things. And, it happens. I remember there was one point where I was working on a ticket, and since I was an engineering manager, I have elevated position or permissions, and I was working on my ticket, made the commits, pushed it to my branch. Oh no, I just pushed to master. And so I had to hurry and quickly roll that back because we had an automated process that would take that, get it tested in our staging environment, get it to production. But I had to quickly roll that back. And then from there, I actually ended up removing engineering managers from being able to have those sort of permissions. That way I prevent it in the future. But if I had something in my checklist that said, make sure you're on a named branch before you push, I would have avoided that. Now, the thing with engineering is like, there's so many things you do day in, day out that you most likely won't forget. But every now and then you do. Now, let's learn what experts say about making checklists. And, take some of this with a grain of salt. This is mostly guidance on, what it's like making a checklist that you're going to give to a bunch of people. So this is what the surgeon made to aid him in making future checklists that he's just going to give to surgeons that they're going to kind of randomly go through. And in a way, it's kind of fun because it's a checklist for checklists. Kind of meta. All right, so the first thing is developing a checklist. So there's these questions you need to ask yourself. Are you using clear, concise language in your checklist? Is each item in the checklist critical or in great danger of being missed? Not adequately checked by other mechanisms? Is it actionable? Designed to be read out loud? So you think about like movies where you see people on the jets. Those are really quick. It's like brakes, check. Windows are closed. Actually, I don't know what they say, but there is one check for pilots where it's like windows are closed. Like if you're a fighter jet pilot, that's one of them, and like you'd think that's like a dumb thing to include on there, but it's on there. It's like just make sure all these things are checked, and if you don't do that thing, like what are the results of that? One that could be affected by the use of a checklist, like you can have good results from it. And have you considered, adding items that will improve communication with your team, involving all the consider involving all of the members of your team in making this checklist. So something to think about if you're going to make a checklist for other people. And then when you're making the checklist, does it utilize natural breaks in the workflow? So with the hospital example, they figured out like, all right, we're going to give anesthesia, we're going to cut open a person, and we're going to have them leave. Those are like good pause points right before those major actions. Let's use those to add checklist items. And I'm just going to run through these, but the gist of it is like, when you're making these checklists, are you making it just simple to use? You got to think about the font. You got to think about where it is. Is it something physical? Does it make sense to be a physical thing, or like on your documentation site if you're an engineer? Something to think about. And then, as you roll it out, are you validating it? Are you trying it out with real people, real engineers? Are you trying it out on yourself? And then do you modify it as you like learn more info? So, I thought it was interesting that this guy, he came out with a checklist for checklists, and that there might be something to glean from there. So, a lot of this information, it comes from this book called The Checklist Manifesto. It's a book I highly recommend reading. He has a lot more case studies that he went through in structural engineering and in skyscraper design. How do they coordinate all these like complex things over time? And a lot of it boils down to checklists. So when I read this book, I was thinking about my own development practices, and I was like, what would my checklist look like? So the checklist I'm going to show you in a minute is one that I've used before, not too heavily. I'd say I'm still in the early days of trying this out, but this is what it might look like. And of course, there's things here that have duplication. You might have things checked by CI that I would manually check, but I think one of the key things that I look at here is, as engineers, we should be able to validate our own work. We shouldn't have something we throw over the wall. We just ship it and hope that it works for our users, or that our QA people will find it if you have QA people. Like this should be something you think about, like, am I shipping the right thing? We'll get into it. I have a few checklist items. All right, so pre-coding, there's a pause. You haven't even started development yet. Am I solving the right thing? There could be more checklist items in here, but this is what I had. I've reviewed the relevant references, tickets, designs, discussions. Make sure you're like internalizing what you're building. I've written or reviewed a test plan or acceptance criteria. How do you know you're done with the feature? That's what that comes down to. I understand the problem I'm solving or the thing I'm building. Once you've done all those things, you know that you can start the coding task. So you start working on your feature, you build it out, and let's say you're ready to make a pull request. Or in this case, I have this one before a draft PR, just something we use. Is the code ready, like really ready to be reviewed by someone? So the code meets the acceptance criteria, test plan, things are working. I'd be confident deploying this to production right now. So you've already like maybe clicked through it or had validation tests, whether it's end-to-end, component level tests, unit tests, whatever it is, validate some of the functionality. The code is validated locally. Personally, I have a few checks that I do locally, even though CI does a lot of them, except for end-to-end tests if they take forever. All the others I validate, and sometimes I do them one by one, or later as I started doing this more, I just made a script that'll run through it that's called pre-flight, and I would just run out my project before I make my PR. So from there, okay, you have a pull request. Personally, what I like to do is have a draft pull request while I'm crafting the PR, because there's things in there. There's like, is the pull request well documented? Is there a good title description? We don't, at JP Morgan where we were working, we didn't have a test plan, or no, not test plan. We didn't have QA testers. And so we'd put a test plan in the pull request. And so if anyone's reviewing it, they would run through the test plan and like add that further validation that you're doing what's right. A step that's like, I've reviewed the pull request. Did I get all the files there? Did I accidentally put in an additional file? Check out CI, see if it looks as expected. This could be pushed to the left a little further as you're thinking about the pull request, but is it too large? Should I break this down so it's easier to review? Do we have like separately deployable chunks? Test plan's easy to follow and validates the changes. Pull request, transition from draft to ready for review. So that's like the very last one. You're like, finish the checklist, get in for review. Now this is the last one. And this is just another pause point before you're actually like merging it, you're deploying it. Is it ready to go live? You think about how you might support it after it merges. You understand the risks, failure modes. What's going to happen with my users when they use this? Are there risks? I'm confident this is ready for merge. And then last but not least, it's merged. And I'm sure you can have different things if you do manual deployments or other checks you want to have in your whole flow. But this was it for me. So, I shared one experience when I wasn't using a checklist, but let's talk about experience I had when I was using a checklist. I don't have like a big one, a big crazy story or anything, but one thing I did is I added this whole checklist to Notion, and I just got it set up so it can be a template. And so for every ticket I pick up, I would just make a new page off this template, and I had a new list that was just for one ticket. That way I was able to just check through each box. And I don't have much to say about it because my development went smoothly. I checked off items. I did the development. I was working in a risky area of our app that affects every single route. It was something global. And since I went through that list and I thought about things a little bit more than usual, made sure I understood the problem a little bit more, and that I validated what I was doing perhaps a little bit more, when I shipped that feature, it's just, silence. Everything went smoothly. And so I feel like, for me, when I did that, it gave me those moments to have extra thought about my software engineering practice and making it better. That's all I got. Thanks.